So the other two methods are substitution and elimination for systems of equations. And the only time I really want you to use substitution is if we have equations where a variable like this is already by itself. If that's the case, then substitution is super easy because now I'm going to take this part of the equation and replace the y down here. So it's going to be negative 7x minus 1 equals x minus 9. So then we just solve for x, so we'll subtract the x from both sides. So we get negative 8x minus 1 equals negative 9. I'll add the 1 over. So I get negative 8x equals negative 8. So x is equal to 1. Then it doesn't matter what equation you plug it back into. I normally plug it back into the first equation. So we got y equals negative 7x minus 1. So y will equal negative 7 times the one we just got for x minus 1. So y equals negative 7 minus 1. So y equals negative 8, which means I have one solution. My solution is 1, negative 8. So again, identify, do you have a variable by itself? And we do in this case, right here in this first equation. So I'm going to take this part of the equation right here and put it where the y is. So it'll be 7x plus 3 times 7x plus 3 times the equation we just have, which is negative 5x plus 30 equals 42. And so 3x plus distribute gives me negative 15x plus 90. Combine my like terms. I get negative 8x plus 90. Subtract 90 from both sides. I get negative 8x equals negative 48. So x is equal to 6. So then I'm going to plug it back into the original equation that we had for y. Negative 5x plus 30. And now we know y, or x is 6. Y is equal to 0. So my final point would be at negative 6 comma 0. So it means we have one solution. If we had no solutions, then it would be, you would have a number equals a number, but they're not the same. And if we had infinite solutions, that means 0 would equal 0. Everything would cancel out, so they would be the same. Let's talk about elimination. Here's how we're going to do this. Elimination is super easy, and I'm going to do it one way. So first, you got to make sure that you have an x, you have a y, you have a number, just like we do in this case. What we're going to do here is we're going to take this 7, we're going to write it up here. We're going to take this 6, and we're going to write it down here. But we always change the sign of whatever number you put at the top. So I'm going to change that 7 to a negative 7. Then we distribute, and we get negative 42x plus 35y equals 196. And do the same thing for the bottom. You get 42x plus 6y equals 132. So those x's will cancel out. So you get 41y equals 328. So then y is equal to 8. Then choose one of the equations. It doesn't matter which one you choose. I typically choose the top one. And you're going to plug that y back in to find your x. Okay, so you get 6x minus 40 equals negative 28. Add the 40 over. So x is equal to 2. So my solution would be at 2, 8. Okay, do another one. So again, take the coefficient that's in front of the first one, make it is negative 4. Take the coefficient in front of the top one, it's positive 1. Always change the sign of the top one. So now we're going to make that 4 positive. So we're going to distribute. So you get 4x minus 28y equals 212. Then distribute the bottom one. You get negative 4x minus 5y equals 19. Those will cancel. The x's should always cancel out. We get negative 33y equals 231. So y is equal to negative 7. So then, again, choose one of the equations. I always choose just the top one. Replace it. So x plus 49 equals 53. Subtract the 49 over. So x is equal to 4. So my solution is at 4, negative 7.